Hello student. You are all preparing for your cbse board examination. This video will help you to understand which are the three theorems which are very important, and it can come in the cbse examination for maybe a 3 marks or it may be 5 marks. But if it comes for the 5 marks, then it will carry one question which is based on the theorem. Suppose you are proving a basic proportionality theorem, then there will be a question based on the basic proportionality theorem for 2 marks. Otherwise, one sure question is there for the 3 marks. And there are only 3 theorems which you have to prepare for this. So today in the video, to prepare you for the examination, I am starting with the very important theorem, that is a basic proportionality theorem. Application of this theorem is very broad, and the use application is there. It is not only for this year, even for the higher class. Basic proportionality theorem is very important for you. Both application as well as proving the theorem is very important. So let us begin. I will begin this one with the statement of the theorem. Statement of the theorem says, if a line is drawn parallel to one side of a triangle to intersect the other two sides in a distinct point, then other two sides are divided in the same ratio. For example, if you go through this statement, there are 2 parts in the statement. First part is, if a line is drawn parallel to one side of a triangle. So if you carefully analyze, you will find that first part, the part which is beginning with the if, is actually what is given in the question or what is given in the statement. So you will write that one as a given, and this one is actually, with the help of this, you will travel and you will try to prove that this line will divide the other two sides of a triangle in equal ratio. So first of all, I will draw a triangle to explain this one. Let's draw the triangle. We can draw one triangle. Name the triangle as ABC. Suppose this is your triangle. Name it as A, B, C. Now, what is known to you? A line which is drawn parallel to any one side of a triangle. Suppose L is a line which divide BC. Which is drawn parallel to BC, and it intersect AB and AC, say at point P and point Q. This is the given part. Now with the help of this, you want to get AP upon PB equal to AQ upon QC. Now how to get this answer? To get this answer, you need to do some construction. Without construction, we cannot prove it. So let us join BQ. Then join PC. And also draw perpendicular from the point P to the line segment AC. Let perpendicular drawn meet AC at the point R, and perpendicular drawn from the point Q to the line segment AB meet at the point S. So there are point S, there is a point R. We are going to use this. This is also perpendicular. Now we will write here that what is known to us. So under the given, you can write what is known to you. Here, first of all, you will write first point, triangle ABC is given to you. Is it clear to you, children? ABC is a triangle. Then second one, second point you can write, as earlier I told you, L is a line which is parallel to BC. So line L is parallel to BC. This we can write under the heading given. Now with the help of this given part, you want to prove it. So this I am writing as a to prove that. To prove that AP upon PB, AP upon PB should be equal to AQ upon QC. AQ upon QC. First try to understand this only, that your aim is to prove AP upon PB equal to AQ upon QC. Now in order to prove this, I made some construction here. Means I told you that draw perpendicular from the Q to S, also draw perpendicular from the P to AC, which meet at the point S and R respectively. So this will go under the heading construction. Under the heading construction you will write. What do you need to write? You need to write that P R. This is P and this one is a R. P R is perpendicular to line segment AC. This is one construction. Second construction is also draw QS, which is QS is perpendicular to AB. And then third one I can write here, third is join BQ, join BQ and BQ and CP, join this. Now after writing the construction given, you already wrote TPT, you wrote to prove that, and then construction. Now using this I am going to start the step of the proof. So under the proof you will write, under the proof. Under this you are going to write first in triangle. Now look here, I am going to take with the help of area of a triangle I am going to prove it. So I will take a triangle APQ, triangle which is formed at the top, APQ. So I am writing here area of triangle APQ. Put a triangle sign. Area of triangle APQ, which is equal to 1 upon 2, and let me tell you, I am taking AP as the base of a triangle. What I take? AP as a base of a triangle. So I am writing 1 upon 2 into AP into, now look here, this is a triangle AP and the height of the triangle is QS. So I will write here QS. Similarly, now one triangle you have taken APQ. So second triangle you take it as a BPQ. Also area of triangle BPQ, which is equal to, now if you observe carefully, triangle BPQ is an obtuse angle at the point P. So area of this triangle will be equal to, if you take a PB as a base, so PB I am taking a base and the height will be the same, that is QS. So I can write here 1 upon 2 into PB into QS. Let it be point number 1. Or say, yeah, you can take it as a 1 and 2. See, this one is a 1 and this is point number 2. I have taken this one as 1 and this is 2. Now, if you divide 1 by 2, divide, let me make a correction, divide 1 by 2. Divide 1 by 2. So when you divide this one, you will get area of triangle. You will get area of triangle APQ divided by area of triangle BPQ, which is equal to this 1 upon 2 cancel, QS also cancel, so you will get AP upon PP. Please make a note of this. AP upon PB, say this is point number 3. Now let me write here. After this I am taking the same triangle APQ. So if I take a triangle, now I am taking a triangle APQ, which is the same. In the first also I took APQ. So triangle APQ, and now I am writing directly area of triangle APQ divided by area of triangle, which one? Now I am taking a CQB. Second triangle, you can see CQP. I'm sorry, CQP. So area of triangle CQ and P. In this, you can notice here that in this one for APQ, now I will take AQ as a base. So it is 1 upon 2 into AQ into, now on the AQ, PQ is a perpendicular. So we will write PQ is a perpendicular divided by 1 upon 2. Now this triangle CQP is obtuse at the point Q. So therefore this will be, if you extend this line, means you can see there is extension of this line. So PQ is also perpendicular to the extension of the line CQ, that is up to the A there is a perpendicular. So 1 upon 2 into QC, which is a base, and perpendicular is PQ. So what will happen here? PQ and PQ get cancelled. PQ cancel with the PQ, half cancel with the half. So you will get AQ upon QC. Say this is point number 4. Now what you see in point number 3, area of triangle APQ upon area of triangle BPQ, which is equal to AP upon PB. And here area of triangle APQ upon area of triangle CQP, which is equal to AQ upon QC. If you observe carefully in point number 3, denominator of the point number 3 is BPQ, area of triangle BPQ. Whereas in the equation 4, denominator of the equation 4 is a area of triangle CQP. So we will try to make area of this one equal to this one. If we can say area of this triangle equal to area of this triangle, then whole numerator upon denominator of third and the fourth will be equal, and then easily we will get this answer, because you can check here. You already got AP upon PB, and here you got AQ upon QC. So from we will write now, you can recall in 9th standard you learn one theorem that if a triangle lie between the same parallel line, or if the triangle lie between the same parallel line and they have a common base, say here in this case PQ is a common base and they are lying between the parallel line say L and the BC. So area of a triangle BPQ should be equal to area of triangle CQP. So let's write this one here. We will write here. I am writing here, but area of triangle CQP should be equal to area of triangle CQP I took here, and here it is BPQ, area of triangle BPQ. Why they are equal? I told you that triangles with common base PQ and between parallel line L is parallel to BC. Therefore, what we can get now? So now, if I point this one as, say this is a point number 5. So with this point number 5, now for point number 3, 4 and 5, we can conclude that area of triangle APQ upon area of triangle BPQ equal to area of triangle APQ to the area of triangle CQP. So therefore, because numerator and denominator of the fraction equation 1 is equal to numerator and denominator of equation 2, therefore we can write AP upon PB equal to AQ upon QC. Hence proved. So this way we can prove basic proportionality theorem. This is very important theorem. Start proving with your own after watching this video.